All right. So, very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th, our ongoing chapter, pressure. And today we are entering into the session number 3. Means so far we completed the 2 sessions about the pressure, where we started learning about what is thrust or force, what is pressure, what are the units of pressure, and what are the various applications of pressure, how pressure changes with force and area. And we have seen various examples like camel walking on desert, or heavy truck containing so many wheels, and a skater in ice skater, how they are traveling easily. Various examples, various applications we have seen to explain about the pressure. Right? So once you will continue where we left in the last class, but before that, let us recall. Let us recall what we learned till now. Right? So this is the thing what we learned in this chapter. First, we started with the what is thrust. So thrust is nothing but the total force acting normally, means perpendicular. Normally on a body is called thrust. The weight exerted by a book. When you place book on a table in front of you, there may be a book. So that is the book exerts some thrust on the table perpendicularly, which is measured in Newton or dyne. So in case of gravitational, in case of that weight is influenced by gravitational force, and that is measured in either kg weight or gram weight. Okay. Then pressure is nothing but thrust per unit area or force per unit area. How much force is acting in a particular area, right? If area is more, pressure is less. If area is less, pressure is more, right? That is P is equal to, the mathematical formula for pressure is P is equal to F by A, force by area, which is measured in Newton per meter square or dyne per centimeter square or Pascal. Pascal, bar, torr, atmospheric pressure. So many units are there for the pressure. Clear? The force or thrust acting per unit area is called pressure. That is our chapter heading, which is mathematically given by P is equal to F by A, measured in Newton per meter square or dyne per centimeter square. Right? Now, applications also we have seen. See clearly, animal like camel. Camels walk easily in desert as compared to horses or donkeys, because they have broad feet. If you observe carefully the feet of a camel, feet of horse, feet of donkey or human being, the camel will have the very broad feet. Because of the broad feet, that is indicates more area of contact on sand. Pressure on sand is less. That is the reason camel can walk freely compared to the donkey or horse. Then a heavy truck. You can see on highways, big trucks will go fitted with 6 to 8 wheels. Ordinary will have only 4 wheels. But heavy truck will have more wheels. More wheels because to cover more area. The total weight on the truck is distributed for more area. More area means less pressure. This increases the area of contact on which their weight acts, and hence reduces their pressure on the ground. The skiers, I told you, those who skate on ice, they also use a very broad skier. The cutting edge of the knife. Suppose when you see the knife using a kitchen for cutting the vegetables or fruits, it is always keep sharp. If it is a blunt, we cannot cut the fruits or vegetables. What we'll do, we'll go for sharpening. While when you are sharpening, the area becomes less. The area is less, the pressure is more, so that you can cut the vegetables easily. Right? And foundation of high-rise building. When you have 10 floors, 20 floors or big buildings, their area, foundation is very wide area. Because area is more, pressure is less on the foundation. So that the building can safely, right? From all these applications, what you understand is pressure is directly proportional to force and inversely proportional to area. More force, more pressure. More area, less pressure. Okay, that is a conclusion what we observed from the applications of the pressure or definition of the pressure. P is equal to F by A. Right, now you come to the fluid. What is fluids? Fluids are nothing but the matter which flows. What? Matter which flows are called fluids. Which flow, like liquids and solids, right? Both liquids and gases, big liquids plus gases together called as fluids. What are they called? Together called as fluids, because we know in liquid or gases, the molecules are apart from each other so that they can flow. Whenever you are dropping some water on floor, it won't stay there only like our duster or pencil. It flow. That's why they are called fluids. So not only solids, either liquids or gas also exerts pressure. So first we'll see about the liquids. Gases will come across in the higher classes or even in chemistry also, right? So a substance which can flow from one point to another point is called fluid. Since liquids and gases can flow, so they are known as fluids. The fluid exerts the many pressures: downward pressure, upward pressure, lateral pressure. Lateral means along the direction. Lateral pressure. Three kinds of pressures are there. Right? So liquid exert downward pressure, upward pressure, and lateral pressure. Along the surface also they exert the pressure. Because of lateral pressure only, the boat or ship can move forward. So because of downward pressure, the body will go inside. Liquid exert pressure will dip into the water. So because of upward pressure, whenever you throw a rubber ball, it will come up because of the upthrust, upward pressure, which is also called as buoyancy, will come across later. So liquids will exert all the three types of pressures. You can see clearly. Examples are given and explanation is given here. Okay. So mathematical formula for the pressure, very important. Mathematical formula is there. So we know pressure is equal to force by area. How you get it? Mathematical equation for pressure of the fluids. Consider a vessel containing liquid of density D. What is there? Density is given by D. Okay. Coin of area of cross section A. Area is equal to capital A. Placed at the bottom, see here. The coin placed at the bottom. A liquid column height H. So this is height H. Height H. Height H and area of cross section A forms the imaginary cylinder above the coin. Read this. This column exerts its weight on the coin, giving rise to liquid pressure. So because of pressure of liquid, the coin will undergo. So for example, you have three values are given. Density is D, area is A, and height is H. So we know mass. So mass is equal to, volume is equal to mass by density. Sorry. Density is equal to mass by volume. Density is equal to mass by volume. Right. From here, we get mass is equal to density into volume. Right. One example. Then same mass is equal to Density you can write density only. Volume you can write area into length. Area into height. Length into area is nothing but volume only. What is volume? Length into breadth into height. Right? So volume is nothing but length into breadth into height. So what is length into breadth is nothing but area only. So in place of volume, we wrote area into h. Correct or not? Right. So from weight is equal to mg formula. W is equal to mg. F is equal to ma. Same only. This formula. So pressure you can write here. So W is equal to A, in place of M, we wrote A HD. A HD into G. In place of M, we wrote A HD. And G as it is. Right? That is W. So pressure due to liquid is nothing but thrust by area. Pressure is equal to thrust by area. Thrust is nothing but weight only. So thrust is nothing but A H D G by A. A cancel. So what will get? Pressure is equal to HDG. Simple. From the definition of mass or from the definition of density. For us, density is given, A is given, height is given. So density is equal to mass by volume, you know, right? Density is equal to mass by volume, from which you wrote mass is equal to density into volume. But what is volume? Volume is nothing but length into breadth into height. Whereas length into breadth is nothing but area. Area into height you wrote. In place of volume, we wrote area into height. Clear? Then from the formula, W is equal to mg, gravitational pressure. So W is equal to, in place of M, we wrote AHD by G into G. But we know pressure is equal to force by area or weight by area. So weight is given by AHDG by area is A. Area cancel. So P is equal to HDG. H is height, D is density, G is the acceleration due to gravity. So whenever you are dropping any object in liquid, the pressure of the liquid can be measured by HDG. How much height of the object from the surface, that is height. What is the density of that liquid you have taken? And G is the constant value, 9.8 meter per seconds. By knowing these three, you can find out the pressure exerted by the liquid. It may be water, it may be alcohol, it may be any other liquid. Clear? The mathematical formula for the pressure is H is equal to P is equal to HDG. Clear? So we learned in the beginning about what is pressure and applications of pressure. Then mathematical equation for pressure also we have seen. Clear? After observing all, we come to some conclusion about the pressure. How pressure exerted in the liquid is proposed in the form of loss of liquid pressure. Right? So pressure at the point inside the liquid increases with the depth from free surface. Suppose here is a free surface, is called this. Say the water is there. This is free surface. Right? Free, outer part. So as long as the object is going into the depth, pressure increases. When you are swimming under the water, the pressure is more when compared to the over the water or lateral. So that is the first point. The pressure at a point inside the liquid increases with the depth from the free surface of the liquid. Means simple. As you go deep into the water, the pressure increases. Right? That is the first law of liquid pressure. Second, pressure at a point inside the liquid at a given depth increases with increase in the density of the liquid. It also depends on the density. That's I've seen now. That is this formula only. P is equal to HDG. Height, density, acceleration due to gravity. That's all. That only explanation. All these three are mentioned in the form of law of liquid pressure. Right? The third one you can see. Pressure is same in all directions about a given point within the liquid. Within the liquid, all pressure is same from all directions. All the molecules of liquid exert same pressure from all the directions. Next, Pressure is same at all points in the horizontal plane at a given depth in a stationary liquid. When liquid is stationary, right? So lateral pressure, the stationary pressure is also same. A liquid seeks its own level. The level will changes whether maybe lower level or upper level or medium. Depends on that also the pressure changes. So whatever the mathematical formula given P is equal to HdG is concluded in the form of law of liquid pressures. They are concluded as a liquid pressure. So before going for the atmospheric pressure and standard pressure, just will show simple small video on pressure, right?
A wooden block kept on a table exerts a force on it, and we know that the wooden block is a solid substance. What about liquids? We know that liquids are kept in containers. Do liquids or fluids exert pressure? Yes, they do. They exert pressure on the base and the walls of the container in which they are enclosed. The pressure on the base will be downwards, and on the walls, the pressure will be sidewards. We can also derive something interesting if we look at the fluid in terms of layers. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal parts. You can see that the second layer of water is holding the weight of the first layer. Similarly, the third layer is holding the weight of the first as well as the second layer. And the fourth layer is holding the weight of the top 3 layers, and so on and so forth. So clearly, the pressure at the bottommost layer is the maximum.
See, as you are going
There's even a way you can find this out. Near the topmost layer, make a little hole at the side. You'll see that the water flows out from that hole like this. It doesn't roll along the walls, it flows out at an angle. Now let's make a second hole near the layer under it. You'll see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the wall, and we'll notice that the water literally squirts out. This proves that the pressure at the bottom is much more than the pressure at the topmost layer. What about the upward force exerted by a liquid? How do we understand that? We will see that in our next video.
Right, you got na? That is just about the what is the pressure exerted. It's clearly mentioned that pressure exerted by liquid is more at the bottom. That is our first law of atmosphere. Correct? Okay. So atmospheric pressure. That is pressure exerted by the atmosphere. Right? You know atmosphere? The thick blanket of air around the earth is called atmosphere. Okay. So the atmosphere also exerts some pressure on any object. That is the force exerted by atmosphere on unit area of the earth's surface is called atmospheric pressure. Very interesting, which is known as, which is either 76 centimeter of mercury or 760 mm of mercury. That we can calculate by barometer. Okay. So the pressure exerted by the atmosphere on unit area of the earth's surface is known as atmospheric pressure, right? So standard atmospheric pressure. The standard pressure is average pressure of the atmosphere at sea level, 276 K, that temperature, and is expressed in the pressure as 1 atmosphere, 1 atm. It is found that 1 atmospheric pressure can be balance a column of mercury 0.76 or 76 centimeter. Thus, the standard pressure is 0.76 meter Hg or 0.76 meter, 76 or 760 mm. Right? We are not aware of this because the blood in our body exert pressure which is slightly greater than the atmospheric pressure. Blood pressure also more than atmospheric pressure. We can express in Pascal as 0.76 m of Hg pressure. We can convert in various forms, Pascals also. 1 atm is equal to 10 power 5 Pascal. Right? 760 mm or 76 mm, all given here clearly. That is the pressure exerted by atmosphere on surface of the earth is called as atmospheric pressure. So how to measure? The measuring of atmospheric pressure, you can see here. Measurement of atmospheric pressure. The instrument used to measure the atmospheric pressure is barometer. With the help of barometer, we can measure the atmosphere. It was constructed by Torricelli, he was a scientist, in 1643. The liquid used in the barometer is mercury. See, they fill the mercury here and they inserted the tube into the same liquid. The liquid raised to the level. So the pressure, because of the pressure here, the liquid is raised to up to certain level, that is 76 centimeters height. So transverse, right? So this is a way to measure the atmospheric pressure. So because of atmospheric pressure on the surface of liquid, the liquid level will raise. It is raised up to 76 centimeter or 760 millimeter or 0.76 meter of Hg. Why you are saying? Because we are using the mercury here. Hg is nothing but mercury, a chemical name of mercury, symbol of mercury, right? So by this way, we can measure the atmospheric pressure at any time by using the barometer devised by Torricelli in 1643. Clear? Right. So let us move forward some more information about the transmission of pressure. How the pressure transmits in the different place of the any body or liquid. See here. So liquid, what as per the Pascal's law, very important. That is a very important law, how liquid transmits. The pressure exerted at any point in a enclosed and incompressible liquid is transmitted equally in all directions. See, this is an enclosed device or it is completely locked here. When you open all the ends, the pressure will distribute equally. It distributes equally in all directions. That is the statement of Pascal law. This distribution of pressure equally on all directions will help us in so many applications. So many applications are there. So force by area given, force by area, first one, second one, all are same here. Take F1 as a force at one point. See 1, 2, 3, 4, 5 are there. So F1 by A1 is equal to F2 by A2, F3 by A3, F4 by A3, F5 by A5. All same only. So that is P1. P1 is equal to P2 is equal to P3 is equal to P4 is equal to P5. Means at any point in enclosed level, the pressure exerted by liquid is same. See, if you want, you can take one balloon, fill with water and make holes at the various points. So all the water will come out through the balloon with the same pressure. Okay, that is called Pascal's law, which explains about the transmission of pressure in liquids is given by Pascal's law, which says that the pressure exerted at any point in an enclosed and incompressible liquid is transmitted equally in all directions. So where we can see this, what are the applications of Pascal's law? We'll see. Means where this law is applicable in our day-to-day life. The working of hydraulic machine, such as hydraulic press, hydraulic jack, hydraulic brakes. Hydro means water. Hydraulic means water pressure. Hydraulic machines like hydraulic press will use this hydraulic press to crush the cotton seeds, oil seeds. From seeds you can get oil by using the water pressure. Right? Hydraulic jack for lifting the heavy vehicles. For example, when you take your four-wheeler to the servicing station, when you go, they place the car on pit. That is called pit. They place on pit and they'll apply the hydro pressure so that car will raise up. Then they'll go for the washing. The pit is lifted up with the pressure of water, liquid pressure, which is called hydraulic jack. Even you can use for the lifting the vehicle for puncture. Instead of manual, we can have the hydraulic jacks. Hydraulic brakes also there nowadays. Heavy vehicles can get the hydraulic brakes. It holds properly instead of brake liners and all. With the help of the water pressure, we can stop the vehicles. So we can crush the seeds, either it is cotton seed or oil seed, to get the oil. They're also used to lift the vehicles. They're also used to as a brakes also. All these cases, the pressure works is on liquid only. Liquid pressure will come. Example you can see. It is used for compressing the cotton bales. Cotton bales means cotton bales will come. It is used to extracting of oil from the oil seeds. It is used to for the puncturing holes in the metals. Punching holes. By using this, you can punch the holes also. It is used for servicing automobiles in a servicing station. You can use that they are used to lift the vehicle and you can do the service. Right? All these examples will give the applications of the liquid pressure. Where liquid pressure happens, that everything can be seen here. Applications. Okay. So these are the things about the pressure. If anything is there, we'll see. If not, we have to go to the next chapter. So that's all for this. So this total chapter, what is thrust, what is pressure, applications of pressure, mathematical expression of pressure, then atmospheric pressure, and then finally the liquid pressure, where you can see the examples where the liquid pressure exists in the form of hydraulic machines like hydraulic jack, hydraulic brakes. All these are the examples where we can see the pressure. So there is a further explanation is there, lot is there about pressure, which we learn in the next 8th, 9th and 10th classes. Right? So this is total about our chapter, probably the 5th chapter. Then we move to the next. Tomorrow when you meet again, we'll go for the next new topic. That is heat chapter in the next chapter. But till now, that's all for today. What we learned entirely about the chapter pressure. So tomorrow when you meet, we'll have the new chapter. That is chapter number 6. Chapter number 6 has heat. We'll discuss about some important concepts of heat in the next chapter, right? So thank you, students. Have a wonderful day. Thank you.